In our last class, we have studied the chapter Organic Compounds Containing Nitrogen, and in our first class, we came to know about the classification of nitrogen containing compounds. It can be classified into primary, secondary, and tertiary based on the nature of the carbon atom, the nitrogen attached. And after that, we have seen the IUPAC of amines. Now, today we'll see the preparation of amines, the different methods of preparation of amines. Amines are prepared by the following methods. So we have got around 7 methods. We'll see one by one. The first method is reduction of nitro compounds. That means we can obtain amines by reducing nitro compounds. So we can use the reducing agent like finely divided nickel, palladium or platinum, or we can also carried out by the use of, you can see in the second one, tin and HCl or iron and HCl. Now if you take a nitro compounds, and if you treat with the hydrogen, addition of hydrogen with reduction in palladium in presence of ethanol, you'll get aniline. That means this NO2 group will be reduced to NH2. Similarly, instead of this, we can use tin and HCl or iron plus HCl. You'll get NH2 group. So from nitrobenzene, we came to know that by reduction we can get aniline. Next, the second method is aminolysis of alkyl halides. Now we'll see what does this aminolysis means. Say for example, let us try to understand with the help of a chemical reaction. Ammonia, we have taken ammonia and we are reacting with alkyl halides. So as we know, alkyl halides, halogen atom is attached to a carbon atom, so the bond is polar in nature, and if the bond breaks, it will break towards the halogen atom, either chlorine, fluorine, because of electronegative element. So this will carry a negative charge and this will carry a positive charge, and ammonia contains a lone pair of electron which can take the positive part from the alkyl halide. So when it happens like that, it is going to form this substituted ammonium sulfate. That means R will get added to that, and this will be X minus. Now to stabilize, because here nitrogen has got 4 bonds and it has a positive charge, to stabilize, what will happen, out of this 3 hydrogen atom, one hydrogen will be removed as H plus. One hydrogen will be removed as H plus. Now, and the remaining compound to obtain will be RNH2, that is primary amine. Similarly, if you take one more molecule of alkyl halide, one hydrogen of that will be substituted and it will form R2NH, which is secondary. And similarly, if you take one more molecule, it becomes R3N. One more, it will become to quaternary ammonium salt. And this process of cleavage, that means breaking of carbon halogen bond by ammonia, is called as ammonolysis. Next method, we have got reduction of nitriles. Nitriles means cyanide compounds having CN group. So we can take alkyl cyanide. When you reduce it, that means hydrogen in presence of nickel, or you can take sodium amalgam in ethyl alcohol. It will form amine. That means this RC triple bond N, here there will be addition of 2 hydrogen and here there will be addition of 2 hydrogen, so we'll get CS2NH2. So we can get amines by the reduction of nitriles. Instead of this, we can use also lithium aluminum hydride. It is also a good reducing agent. Next, number 4, we have got reduction of amides. We can also obtain amines by the reduction of amide compound. Amide means this compound, RCONH2 group. This group we call it a amide group. Now this on reduction, similarly with the lithium aluminum hydride, which is considered as good reducing agent, it will reduce this CO group it will reduce this C double bond O group into CS2 and it will get amines. This is the fourth method of preparation of amines. Next, a very important method, Gabriel phthalimide synthesis. We have to understand the mechanism for this. That means how we can prepare amines from it. Basically, this Gabriel synthesis is used for the preparation of primary amines, where the NH2 group will be attached to only one carbon atom, alkyl group. Okay, say for example, let us take the structure of phthalimide is this one, benzene ring, where we have got carbon carbon double bond, NH, again it is C double bond O. This is called a phthalimide. So in this reaction, the first step will be this phthalimide will be treated with potassium hydroxide. As we know, potassium hydroxide is a base. It will liberate OH minus and this will be a K plus. So in this OH minus will take this H and it will form an water, whereas this nitrogen, which is contains lone pair of electron, it will take a positive potassium ion and it will form a salt like structure first, N minus K plus. Okay, after that, when you treat this with alkyl halide Rx, what will happen? This is negative, this is positive, so from this part this is positive and this negative, so N minus will take R, that means alkyl part, whereas K will go along with X and it will form potassium halide. Okay, now this compound will be called as N-alkyl phthalimide. Okay, now this compound, when treated with sodium hydroxide, what will happen? NaOH. So from this part, NaO will go along with this carbonyl group, C double bond O, ONa, and one hydrogen will attach over here. And similarly, if you take one more molecule of sodium hydroxide, same thing over here, C double bond O, ONa, and this will be NH. So you'll find this compound plus from this part NH and NH, it will form RNH2, that is a primary amine. This method is known as Gabriel phthalimide synthesis. Next, a very important naming reaction. If I have to rate, I'll give it 5 star. Now, Hofmann bromamide degradation reaction. It is a very important reaction, as I'm saying. So let us see what is the reaction. In this, we take an amide group, amide functional group. Amide functional group is treated with bromine in presence of sodium hydroxide, and this is alcoholic in nature. So what will happen? This CONH2 group, when you treat with bromine and sodium hydroxide, this CO group will be removed and it will form RNH2, which is a primary amine, and plus sodium carbonate plus NaBr plus 2H2O. Okay, this is the reaction for Hofmann bromamide degradation reaction. Okay, since it was developed by Hofmann, it is named after it, bromoamide. Why it is called bromoamide? Because there is the addition of bromine. And degradation means to decrease. So over here, what is decreasing? If you see in the amide, we have got this CO group, but in the product, in amine, we don't have that carbon atom. That means one carbon atom is getting degraded or less. Because of that, it is known as Hofmann bromide degradation reaction. And the last preparation is from alcohols. Aliphatic amines can be prepared by passing vapors of alcohol and ammonia over heated alumina. So if you take ethyl alcohol and react with ammonia in presence of aluminum oxide, what will happen? This OH will take one hydrogen from here and it will form water, whereas this NH2 will get substituted over there, so you'll get primary amine. Similarly, if you take one more molecule of this ethyl alcohol in presence of aluminum oxide, one hydrogen of this will be removed. That means ethyl group will be added over here, so it will form a secondary. Further reaction, it will form a tertiary. Is that clear? So these are the few preparations of